All right. Going to talk about negative and zero exponents today. Anytime you have a number or a letter raised to the zero power. So if I have 4 to the zero power, any number raised to the zero power is always equal to 1, no matter what the number is. 10,000, 10,500, a million. Okay, even if I was to raise a to the zero power, a to the zero power is still just 1. Okay, so any number raised to the zero power is equal to 1. Okay, now, having said that, if I have, for example, 2 to the second would be equal to 4. 2 to the first would be equal to 2. 2 to the 0 would be equal to 1. 2 to the negative first power would be equal to 1 over 2. 2 to the negative 2 power would be 1 over 4. So if you will look at those two, okay, if we look at those two, and we have 2 to the second is equal to 4, and 2 to the negative second is equal to 1 over 4. Okay, so you will see a pattern here. Same thing we had here with 2 to the first power equal to 2, and 2 to the negative first power equal to 1/2. And what is the pattern? What are we doing to the number, the positive exponent number versus the negative? Copeland? There's a variable somewhere in there? I'm making a fraction, but what kind of fraction? No. I'll give you a hint. It starts with an R, and we've already talked about it. No. What do we do when we're dividing fractions? What do we do to the second number? No. No. This is why y'all don't need to cram the night before a test and actually learn the material. It's the reciprocal. Okay, the reciprocal of 4 is 1 over 4. The reciprocal of 2 is 1 over 2. The reciprocal of 9 is 1 over 9. Okay, so when you raise something to a negative exponent, for example, if I had 5 to the negative third power, okay, this negative sign has nothing to do with whether the number is positive or negative. It means to do the reciprocal of the base. The base is the large number, the exponent is the smaller number. So it means to do the reciprocal of the base. The reciprocal of 5 is 1 over 5. Now I'm going to raise that to the third power. Okay, that raised to the third power would mean 1 over 5 times 1 over 5 times 1 over 5. Which that is 1 over 125. Because 1 times 1 times 1 is 1. And then 5 times 5 is 25. 25 times 5 is 125. And so the answer to 5 raised to the negative third power is 125. It is not, once again, the negative exponent has nothing to do with whether the number is negative or positive that you end up with. Okay? So, if I have this, x to the negative sixth power. Okay, well, x to the negative sixth power is 1 over x to the sixth. If I had m to the negative second power, well, that is 1 over m to the second power. So what if I had this? 18 times f to the negative first power. Well, 18 is 18 over 1. Okay, this says do the reciprocal of f. The reciprocal of f is 1 over f. The base is f, so I do the reciprocal of f, which is 1 over f. Now I multiply those back together. 18 times 1 is 18. 1 times f is f. So that is that expression simplified. So what if I had this? 6g raised to the negative fifth power. You have to remember that these are two separate terms that are being multiplied together. So if I just take g to the negative fifth power, how do I write g to the negative fifth power with positive exponents? Not everybody at once. How do I write g to the negative fifth power with positive exponents?
1 over g to the fifth?
Yes, 1 over g to the fifth. Okay, that's how you would write g to the negative fifth power with positive exponents. Now, 6 is just 6 over 1. So that's there, and that's there. Multiply the two together. And you get 6 over g to the fifth power. As I stated 5 times now, the negative exponent has no effect on whether the answer is negative or positive. It is telling you to do the reciprocal of the base. You heard me that time, right? Okay. Just making sure, because I've said that 5 times now in a 8-minute span. Okay. So if I had this one, it doesn't change. If I had c to the third power times d to the negative first power. Those are two separate things. There and there. So that's c to the third over 1 times 1 over d. Now I multiply those two things together. That would be c to the third over d. Now you could put d to the first, but there's no need to. But if you want to, that'll be fine. It's not going to be wrong. Okay? That's how we write that expression using positive exponents. Now, understand that they may also do this. And they tell you to write it with positive exponents. That's how you write it with positive exponents. If it tells you to simplify it, okay, this is writing with positive exponents. If they give you 6 to the negative third and they tell you to simplify or evaluate, then you've got to take it one step further. That's the first step. And then you've got to take 6 times 6 is 36. 36 times 6 is 216. That's what that answer is if they tell you to simplify or evaluate it. If they tell you just to write it with positive exponents, then that's all you have to do. Okay? Now they're going to see if you can reverse this order. We said that 5 to the negative second power, 5 to the negative second power would be what? Simplified. What? 1 over 25. Okay, 1 over 25. Now, this is simplified. If they told me to write the expression without using a fraction bar. So in other words, they give me 1 over 25, and they want me to write that without a fraction bar, then I'd convert it back to where we started, and it would be 5 to the negative second power. Okay, let me show you another one of those. 1 over 64. And they want you to write that without a fraction bar. Okay. 1 over 8 to the second. Yeah, be 8 to the negative second power. Okay, or 2 to the negative 6 power. Because 2 times 2 times 2 times 2 times 2 6 times is 64 as well. What if I had this 1 over 19? How can I write that without the fraction bar? What? No. Yeah. 19 to the negative first power. That's how we write it without a fraction bar. So if I had this then, 9a to the second over b to the fifth. How do I write 9 times a to the second over b to the fifth without using a fraction bar? The key is just to look at this right here. How do I write in other words, how would I write 1 over b to the fifth power? No, without a fraction bar. b to the negative fifth power. That's how you write that without a fraction bar. So, then my answer then would be 9 times a to the second times b to the negative fifth power. Huh? Yeah, because if I have 4 over 1, how do I get rid of the fraction bar besides just not writing it like you do? What is 4 over 1? Just 4, right? Okay. So I don't have to have a fraction bar to write 4 over 1. So 9, this expression right here is the same as this. 9 over 1 times a to the second over 1 times 1 over b to the fifth. That expression is exactly the same. So 9 over 1 and a squared over 1 are already whole numbers, and I don't have to use a fraction bar to express those. All right, now, here's where we're going to take and what we learned the last 2 days, or Friday and Monday, Friday of the week before Thanksgiving, and then Monday yesterday, to solve or simplify this problem. Okay, I have 3 to the 4th power times 3 to the negative 7th power. Okay, the directions tell us to find the product, write your answer using only positive exponents. Okay, so it says to find the product and write your answer with only positive exponents. So if I take 3 to the 4th times 3 to the negative 7th, that's the same thing as 3 to the 4th plus negative 7, because we add the exponents when you're multiplying. Well, what is 4 plus negative 7? Negative 3. So is 3 to the negative 3rd power a positive exponent? No. So I have to convert it to 1 over 3 to the 3rd. And that's your answer. Didn't tell us to simplify it, and didn't tell us to evaluate it. So therefore, we don't go down all the way to, we don't go down to 1 over 27. Okay, we just leave it as 1 over 3 to the 3rd. So I want you to try this one on your own. 10 to the negative 2nd times 10 to the negative 8th power. And write your answer using only positive exponents. Joshua, what'd you get?
1 over 10 to the power.
Yes, 1 over 10 to the 10th. Here you have 10 to the negative 2 plus negative 8 power. Negative 2 plus negative 8 is 10 to the negative 10th power. I can't use negative exponents, so that tells me to do the reciprocal. So I do the reciprocal of 10, which is 1 over 10, and then I put the exponent with it. So what about this one? 5t to the negative third times 3t to the negative eighth power. Copeland, what did you get? Nope. Joshua? Nope. Gracie? Huh? Okay. Nope. 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 All right, let's look. Remember, hush, hush. Remember, the commutative property says I can do this. Okay? So when you were learning your multiplication tables in first, second, third grade, whenever it was, 5 times 3 was 1 over 15. What is 5 times 3? 15. Just 15. Then that is, this part of it is t to the 3 plus negative 8 power. What is 3 plus negative 8? 3 plus negative 8?
5.
Oh, it is, hang on, it is negative 3, my bad. I forgot that negative part. Okay, so that's t to the negative 11th power. Now, this only applies to the t. So that's 1 over t to the 11th. This is 15 over 1. Multiply the two together. Okay, you are trying to add, take 5 and 3 and say you have like 5 to the second power. No, you don't. There's not the same bases. The only bases that are the same is the t. And then the exponent with the t only applies to the t. It doesn't apply to the whole thing. Madison?
On the other one, you didn't multiply 10 and 18.
Huh?
You didn't multiply 10 and 18 on the other one.
10 and 18.
Yeah. On the other one, because we did 5 and 3 on this one. Yeah, where you add
Yeah, well, because
powers there.
that's 10 and 10.
It looks like
It's 10 and 10.
wait, you didn't add it.
What do you mean I didn't add it?
I thought it was,
I added it right there.
but you didn't add, but you did 3 and 5.
Well, I multiplied because 5 and 3 are not the same base.
Oh, is there?
I multiplied them together. For this to be the exact same problem, it would have had to look like this,
I got 5 in the first power.
like that. Then yes, I would have to take the bases, but it still wouldn't give me 1 over 5. At that point, you're looking at 5 to the second times t to the negative 11th, which then would give you 5 to the second over t to the 11th. But they didn't have the same base, so you can't do that. The only time you can add the exponents is when they have the same large number. Okay, so what if you had this 4 times a to the 0 power times 7a to the negative 4th power? Okay, well we just said that anything raised to the 0 power is 1. So that's 4 times 1, which is 4. So 4 times 7 times a to the negative 4th. Remember what I said the other day? That's the same problem. It's just 3 numbers that you're trying to multiply together. Well, 4 times 7 we can multiply together and get 28 times a to the negative 4th power. Well, what is a to the negative 4th power? No, 1 over a to the 4th. So this is 1 over a to the 4th. This is 28 over 1. And I'm multiplying it together. And that's 28 over a to the 4th power. So what about this? 2 to the 5th over 2 to the 8th. We said yesterday, when we finished up yesterday's lesson, we said, what do we do to exponents when you're dividing them? We subtract the exponents. So this is 2 to the 5th minus 8. What is 5 minus 8? Negative 3. So that would be 2 to the negative 3rd power. They want it in positive exponents. So that's 1 over 2 to the 3rd. What, Nicole? You had your hand up. Yeah. Okay. So what if we had this? 4 to the negative 2 power over 4 to the 6th power. The base stays the same, and we subtract the exponents. What is negative 2 minus 6? No. Negative 8, because that's 4 to the negative 2 plus negative 6 power, which is 4 to the negative 8th power, which is 1 over 4 to the 8th. Okay? Your homework. 4.6. 16 through 39 and 43 through 46. You may go.